to whomsoever it may concern. This video is the practical demonstration of trigonometry. Trigonometry was derived from an unit circle. Hence, before we discuss about trigonometry, let us understand what is an unit circle and its representation. A unit circle is a circle with its radius is equal to 1 unit. 1 unit can be either 1 millimeter, 1 centimeter, 1 feet, 1 meter, 1 kilometer, or 1 mile. Here, the unit of measurement is least bothered. The center point of an unit circle is coinciding with the intersection of vertical and horizontal axes. The vertical and the horizontal axes are graduated from 0 to 1 in positive and negative directions for both horizontal and vertical axes. The step increment is 0.1. The circumference of the circle is graduated from 0 to 360 degrees with a step increment of 10 degrees. An infinite construction line is used to locate the subtended angle. This construction line will travel through all angles and it passes through the center of the circle. Key point to note here is this construction line can be either exactly vertical or exactly horizontal, or it can take any angle. I repeat, this construction infinite line can be either perfect horizontal, perfectly vertical, and can take any angle when it is rotating across the angular graduations. Having understood about the construction line, let us proceed with the direction of measurement of an angle. The angle is measured in counterclockwise direction from 0 to 360 degrees. let us locate the angles and try to measure the arc length associated with the different angles. At 0 degrees, the measured arc length will be 0. At 10 degrees, the measured arc length will be 0.17 units. At 20 degrees, the measured arc length is 0.35. At 30 degrees, it is 0.53. At 40 degrees, it is 0.7. At 50 degrees, it is 0.87. At one particular angle, the measured arc length will be equal to its radius. In this case, unit circle has a radius 1 and the measured arc length is also 1. The angle at which the arc length will equals its length to the radius of the circle, that angle is called as 1 radian. The magnitude of that angle in degrees is 57.3. We call 57.3 degrees as 1 radian. We can represent the complete circle with 360 degrees, or we can represent the circle with 6.28 radians. When we can represent a complete circle in 6.28 radians, then we can represent half of the circle in 3.14 radians. That's the reason why 180 degrees is also called as 3.14 radian. 3.14 is the value when we divide complete 180 degrees by 57.3 degrees. This value will have number of decimal places. Hence, this has been truncated to 3.14. Or this value can also be represented by a symbol called as pi. When 180 degrees is represented as pi or 3.14 radians, then the 360 degrees can be represented as 2 pi or 6.28 radians. The circle can be represented now either in degrees or in radians. Hence, to measure the angle, we have two units, either degrees or radians. Now, let us proceed to understand the trigonometry. For that, let us come back to the first quadrant. Now we'll discuss about what is a sine, what is a cosine, and what is a tan. How they are going to vary, why they have the different values, Why they have the different signs? We say at particular angle, these will change their value to zeros or 1 or infinity. How does this work? The secret of the trigonometry is now revealed. Let us understand what is a sine. Listen to the definition carefully. Sine is the name of the line which is projected from the end of an arc to the horizontal axis. I repeat, sine is the name of the line which is projected from end of an arc to the horizontal axis or x-axis. This line is called as sine. Sine is simply the name of one line. Now let us understand what is cosine. Cosine is the name of the line which is projected from center of the circle to the sine. I repeat, cosine is the name of the line which is projected from center of the circle to sine. Let us understand what is a tan. Tan is the name of the line which is tangent to an unit circle starting from the beginning of the arc and intersecting with the angle subtending line. I repeat, tan is the name of the line which is tangent to the unit circle and starting from the beginning of an arc and intersecting to the angle subtending line. At this point, it is clear that sine, cosine, and tan are simply the name of the lines. Now we'll understand the behavior of the line when we change the angle. Focus only on the sine. As I go on reducing the angle to 0, the sine is taking the value of 0. And when I increase the angle, its height is go on increasing, and when I reach 90 degrees, it has taken the height equal to the radius of the circle. When I cross 90 degrees, its height again will start decreasing. And when I move towards 180 degrees, its height again goes to 0. When I still continue from 180 degree to 270 degrees, its height again go on increasing in the negative direction. And at 270 degrees, its height will be equal to the radius of the circle. When I cross 270 degrees, its height will go on reducing. And when I reach 360 degrees, again it takes the value 0. Now let us understand the behavior of cosine. As we have already discussed, the name of this line is cosine. Let us come to 0 degrees. When we are nearing to the 0 degrees, the length of the cosine is equal to 1. When we go on increasing the angle, the cosine length will go on reducing. And when we reach 90 degrees, the length of the cosine will disappear and it takes 0 length. When we move more than 90 degrees, the length of the cosine will go on increasing again in the negative direction. And when we reach 180 degrees, its length will be again equal to the radius of the circle. When we cross 180 degrees, its length will again go on decreasing. And at 270 degrees, its length has reached 0 value. When we cross 270 degrees, the cosine length will again go on increasing from 0, and at 360 degrees, it will take the value equal to the radius of the circle. Having understood about the behavior of sine and cosine, let us understand the behavior of tan. We have already discussed that the name of this line is tan. When we are going towards 90 degrees, the height of the tan is increasing. As we go on increasing the angle, the tan height is increasing drastically. And when we are close to 90 degrees, the angle subtending line and the tangent line become parallel and they will never intersect. That's the reason why, in this case, the tan has reached a maximum height which we cannot determine. That's the reason we call the tan at 90 degrees is infinity, which means the angle subtending line and the tan will intersect with each other at 90 degrees at infinity. When we cross 90 degrees, the only possible intersection will happen at the quadrant 4. As we go on increasing the angle, the height of the tan will go on reducing. You can observe here, this is the only possible intersection with an infinite construction line for the tangent. And when we reach 180 degrees, the tan will take the value equal to 0, which means the height of the tan cannot be measured. When we cross 180 degrees, the height of the tan will again go on increasing, and when we are close to 270, the angle subtending line and the tangent line will become parallel and the intersection is not possible. When we cross 270 degrees, then again tangent line will intersect with the angle subtending line and its height will go on reducing till 360 degrees, and at 360 degrees the height of the tan will be 0. Having understood about the behavior of sine, cosine and tan with respect to the different angles, let us understand the trigonometry with examples. Please be clear. Trigonometry is measuring the height or the length of these three simple lines at different angles. An example is considered now. Let us consider an example that is 30 degrees. We are going to locate the angle subtending line to 30 degrees. 30 degrees can be also expressed in radians. In radians, the 30 degrees can be represented as 0.52. At 30 degrees or 0.52 radians, we need to check what is the height of sine, what is the length of cosine, and what is the height of tan. For measurement purpose, let us project the apex of sine and tan to the vertical axis. Now start measuring the height of sine. Sine reads approximately 0.5 at 30 degrees or 0.52 radians. Let us cross check. Sine reads 0.5 at 30 degrees or 0.52 radians. Similarly, cosine reads more than 0.85 at 30 degrees or 0.52 radians. Cosine reads 0.87 at 30 degrees or 0.52 radians. Similarly, tan reads more than 0.55 at 30 degrees or 0.52 radians. Tan reads 0.58 at 30 degrees or 0.52 radians. Trigonometry is so simple. It is just measuring the height or the length of three simple lines. Now let us discuss what is inverse of trigonometry. Inverse of trigonometry basically means, let us pause here. Till now we have understood measuring the height of lines at different angles, which means we know the angle and we measured the height or the length of sine, cosine and tan. When the angle is not known, instead of the angle, the length of or the height of any one of the member is known, then angle can be determined. That is called as inverse of trigonometry, which means sine inverse of 0.5 is equal to 30 degrees or 0.52 radians, or cosine inverse of 0.87, cosine inverse of 0.87 is equal to 30 degrees or 0.52 radians, or tan inverse of 0.58 is equal to 30 degrees or 0.52 radians. Tan inverse of 0.58 is equal to 30 degrees or 0.52 radians. Let us consider the next example, say 0 degrees or 0 radians. The sine is 0, tan is 0 and cosine is 1, which means when we are at 0 degrees, the cosine will take the value equal to the radius of the circle, and radius is equal to 1 for an unit circle. Sine and tan have disappeared, which means they have taken 0 value. Let us consider 45 degrees. At 45 degrees, the sine is 0.71, cosine is 0.71 and tan is 1. 45 degrees is also equal to 0.78 radians. Let us locate 45 degrees. At 45 degrees, try to measure the height of the sine and length of the cosine and height of the tan. At 45 degrees, the height of the tan is measured as 1. The height of the sine is measured as 0.7. The length of the cosine is also measured as 0.7. Inverse means when cosine is 0.7, the angle is 45 degrees or 0.78 radians, Or when sine is 0.7, the angle is 45 degrees or 0.78 radian. Or when the tan is equal to 1, at that time the angle is equal to 45 degrees or 0.78 radians. Let us measure at 90 degrees. 90 degrees also equal to 1.57 radians. The sine will be 1, cosine is 0, and tan is undefined. Which means when we move towards 90 degrees, the sine height is equal to the radius of the circle, which is 1. The cosine has disappeared and the tan is intersecting with the construction or the angle subtending line at infinity. Now let us proceed to the quadrant number 2, which is more than 90 degrees or more than 1.57 radians. Let us consider an angle 150 degrees or 2.6 radians. At 150 degrees, the sine measures 0.5, cosine measures minus 0.87, and tan measures minus 0.58, which means when we locate 150 degrees, the measured height of the sine is 0.5. The measured length of cosine is in the negative direction, which is minus 0.87, and the measured height of the tan also is in the negative direction, which is minus 0.58. Let us consider the next example, say 180 degrees. At 180 degrees, the measured height of sine is 0, tan is also 0, and cosine is minus 1. Which means when we reach 180 degrees, the height of the sine and tan have taken 0 value, and cosine has taken its length is equal to the radius of the circle, which is 1, because unit circle. Let us enter into the quadrant number 3 and locate an angle 220 degrees. At 220 degrees, the measured height of sine is in the negative direction, which is minus 0.64. At 220 degrees, the measured length of cosine is minus 0.77. At 220 degrees, the measured height of the the measured height of the tan is 0.84. A key observation here is, in the third quadrant, the cosine and sine have taken the negative values, but whereas the tan reads a positive value. Let us proceed towards 270 degrees. At 270 degrees, the cosine has reduced its length to 0. The sine has taken the maximum value of the radius, that is 1, and the tan is intersecting with the angle subtending line at infinity. Let us cross 270 degrees and locate 330 degrees. At 330 degrees, the measured height of the sine is minus 0.5, or the measured length of cosine is 0.87 positive, and the measured height of the tan is minus 0.58. Let us proceed to 360 degrees. At 360 degrees, the sine and the tan will take the value 0 and the cosine will take the maximum value of the radius, that's equal to 1. Thank you for watching this video. If you find this video helpful, then please press the like button to like this video. Please share this video by clicking on the share button to your friends, classmates, subordinates, family members, colleagues, teachers, your superiors. Please subscribe this channel for more videos by clicking on the subscribe button just below this video. Thank you.